I'm Laura Filament, and my final project is on Solr search engine. So what is Solr? Solr is an open source search platform, and it is built around the Lucene search engine, or search library. So Lucene provides the ability to add documents to an index. Documents contain fields, and so documents are, or Lucene is great for searching because documents are indexed using an inverted index. So this means that if someone wants to search on the query, search using the query cat, then when they want to find all the documents relevant to the query cat, when these documents were added to the index, the document got parsed into tokens, and then each token was then associated with that document identifier and gets added to the index. So when Lucene finds out that a user wants to search for cat, they look up the index and they say, okay, cat is associated with documents like 1, 4, and 7, and it'll return those. And that's a lot faster than having to search across the entire corpus of documents every time that you want to search for cat. So Solr is built around this Lucene search engine, and it provides additional features. One of the nice things that it provides is APIs to like REST-like APIs that return the set of documents in like a JSON array or in an XML format. And it also provides stuff like faceted search, geospatial search. So for faceted search, if for instance you had, so for the example that you'll see later for my demo, I got I got a set of data about inmates that got admitted to prison from like 2008 to 2010, and there's a bunch of fields associated with each inmate. So gender, age when they were admitted, what their worst crime was, where they came from, and this is all in New York State. And so if you wanted to have a faceted search on these documents, so maybe you wanted to say, give me all the male inmates or give me all the female inmates, you could facet on those parameters. Or you could facet on, say, age ranges. So you could say, give me all the inmates who are from age 35 to 40 or 40 to 45, and it would return those documents as well. Geospatial search is a cool thing because you can associate locations with documents. So if you wanted to find documents that are, if you had documents that are located, like there's a location associated with each document, and you, maybe it's a restaurant or something, and you are located at point 00, and you want to find all the restaurants that are like 5 points away from you radius. Well, those restaurants have those locations associated with them in the index, and Solr can find the things that are 5 points away or within. And so there are a lot of applications that use Solr that we know of. Instagram, Comcast, eHarmony, Ticketmaster, and more, and it's it's a very popular search engine tool. Okay, so how is Solr built using a distributed computing setup? So Solr Cloud uses the notion of shards and replicas. So you could have Solr just on one server or one node, but that would be inefficient if your document collection of documents gets to be too big. So you have to break it up. So you would say you have 100 documents. You would hash the documents, and hopefully your hash is good enough that it would distribute it pretty equally across the different shards. So yeah, you have to shard your data. So say document 1 comes in the hash, you distribute it to shard 1, document 2 comes in, shard 2, etc. So now you've got about like 50 or so on here, 50 or so in here. And when you want to look it up in the index is much smaller, so the search speed is going to be faster. But what if your query load is too large? Or because you're still going to have to query both of these. If you want to query cat, you still have to query cat against the documents in here and query cat against the documents in here. So what if you have a lot of queries coming in? Well, you can replicate. So if you've got documents 1, 4, and 7 on shard 1, the replica within this shard is also going to have documents 1, 4, and 7 indexed. And if 2, 3, and 5, and 6 are in shard 2, then it's also going to get copied over onto this replica. And it also, the notion of replicas also helps with the notion of availability. So if one of these nodes goes down, it'll fail over to one of the replicas. And you can shard and replicate as much as you need for your searching needs. So how do the nodes know about each other? The nodes know about each other through this notion of a zookeeper. So when a node becomes available, it'll register itself with the zookeeper, and then the zookeeper will notify the other nodes of the existence of this node. And this is important because, say if someone's trying to index a new document into the collection, they can hit any node, but only leaders can accept writes without having to notify other nodes. So if someone says, "Hey, replica 1 shard 1 or replica 2 shard 1, I want to index this document," replica 1 shard 1 has to figure out which leader to send it to, because maybe it belongs on shard 1, but maybe it belongs on shard 2. So let's determine that the document belongs on shard 2, so replica 1, the replica sends it to shard 2, and then this leader writes that document to the index and then sends notification updates to all the replicas that are in that shard. Yes. So this has the disadvantage that write availability is limited to leader nodes. So in one of the cases that that you could think of, like for Amazon, for instance, you might want to have high write availability if you want to write to your shopping cart. This is the example that someone used in one of the YouTube videos that I referenced later in the report. And you want this because you don't want to turn away your users. You want them to be able to always write to the cart and say, yes, I want this product. But in this system, it can get complicated if multiple nodes can accept writes, because then there's this inconsistent state of, well, this leader got right, or there wouldn't be a concept of leaders in that sense. So like this node got update 123, but this update got 124, and which one's the one that comes after? They have to reconcile that with each other. So this system where only leaders accept writes and then propagate those propagate those updates to the other nodes is more consistent. So it takes less time to resolve these inconsistencies. Okay, so how do we install Solr? So, 1 second. Okay, so to install Solr, you will need to download Solr 5.1.0. It's the latest version as far as I know. And you'll need to have, I've provided it to be on one of the Linux VMs that we've installed for this class because that's just easier. And you will just want to make sure that JDK6 or above is installed and that Java Home is on the path. So yeah, so you get the package and you unzip it, and then you can start using it. I've got 2 demos to show. One is a quick start demo. It's just right out of the box what you can do when you get Solr. And then the other one's the prison inmate data one. So let's log in and just check out the quick start one. So actually I had already started it. So you can see here I have the command bin solr start cloud, and this is just right in the package after we've unzipped it. And so it asks you a couple questions like how many nodes do you want to run, and yeah, what the collection is that you want to put into Solr, how many shards do you want, and how many replicas do you want. So once you get that set up and running, you can look at the Solr admin console. So we can look at this cloud graph. We can see the collection. We have 2 shards, and then we have 2 replicas per shard. The nodes that have the black dot are the leaders. So we can compare this picture to the one that we saw before, where if a write comes in, it's going to have to go to the right leader, and then the leader is going to propagate the updates to the replicas within that shard. Okay, so let's query some data. I'm not sure, I don't remember exactly what's in here, but that's right. Okay, actually, so we don't actually have any documents indexed into here. We just actually set up the core with the configuration. So we will want to actually add data. So let's do that. Okay, so it is posting some data from this JSON file. And Solr is great because it'll accept JSON, it'll accept XML, it'll accept CSV files. It's really flexible. So if we go back in here, okay, so now we actually see 4 documents. Yes, that's right. So this is a small set of data. So I guess this data is related to books. That's right. It's books.json. So we've got like the Lightning Thief. We've got Percy Jackson and the Olympians. I guess it's like a series. So yeah, you could have the series parameter and then the name of the actual book, the author, category. It's in paperback. Genre is fantasy. And you can already just start searching stuff. So you could say, give me fantasy. And you get 3 results back. And so it's searching on all of the fields because that's how the schema was designed. And so when we talked earlier about how Solr is great for having RESTful like APIs, well, obviously, if you were an application that interfaced with Solr, you wouldn't want to go through the Solr admin console. You'd want an endpoint to connect to. So this is the endpoint, so that when some application says, oh, I want to search on fantasy, they can use this URL with the query fantasy, get this data back in JSON format, and then they can render it in some pretty way using HTML. And you can ask for different responses. So you could actually ask for like Ruby or Python. So if we did that, then we get Ruby. Or XML, we get an XML format. So it's really flexible. So what is next? So what else can you do? You can search directly on some of the fields. So you could say, I want the price of my book to be 12 or above. And I guess you get 3 books back, 12.5, 12, 30.5. But we saw that there were 4 documents before, so 1 got excluded. So we can just double check that. Actually, we'll do 11. Okay, so the price here is $6.49. So yeah, so Solr is great for querying on parameters, querying generally. We talked earlier also about faceting. So here you could facet on, let's facet on the field author. So yeah, so here we see there's 3 authors, but there's 4 books. So one of these is, 2 of the books are mapped to 1 author, and so you could facet and get all the results back for that. Yes. Okay, so that's the quick start, but we want to index some big data. So let's stop the Solr core instance and remove the data. Okay, so now it's stopping Solr. and then if we try and connect back to the Solr admin console, we'll see that that doesn't work too well when it's not running. Okay, so yeah, we can't connect. So let's use some big data. So I got a CSV file from this catalog.data.gov place, and it's about, how many kilobytes is it, or megabytes? I think it's on the scale of, it's about 11 megabytes. It's not too big, but it had some nice fields that I thought would be nice for searching, and it's big enough. So the first thing I did after downloading the CSV file is I modified the fields to be a little bit friendlier. So for Solr, because I'm actually not sure exactly what happens. Before it said like admission space year, admission space month, but Solr needs the fields to be of a certain format. So I just wanted to make it easier and not have to guess about what was going to happen to the fields. And I also added an ID field. So this is the unique identifier for each prison inmate. So yes, each section of data is a prison inmate. So this first person was admitted in 2013 of December of 2013. I'm not exactly sure what the admission type is. I think it's either like a new inmate or if you were on parole or something and came back. I'm not sure. And the county that you were committed, last known residence, what gender you were, so this one's female, age 28, 17, blah blah blah, most serious crime, assault, burglary, etc. So yeah, I thought this would be interesting to search. So after you've modified the CSV file to be of a friendlier format that you know that can be imported, you will want to set up a schema. So a schema is how Solr knows what fields you want to index. So here we've just got a direct mapping from the CSV file to the schema.xml. So here we've got like the field types that we want, and so string, it matches to some Solr Java class. So stir field, that makes sense. Long, tree long field makes sense too. And then the fields that we want. So again, ID, admission year, admission month, gender, age, most serious crime. This version field is necessary for the cloud version because of the fact that it's distributed, when a leader sends an update to one of the replicas, the replica needs to know if it has the most up-to-date version or not. It's possible that you could get two updates and they could come to you in the wrong order. So if an earlier update comes to you um, after a later update came to you, you just want to ignore it as a replica node. We've also got these dynamic fields. So this allows, if we want to index into this, if we want to add documents to this index and add fields dynamically, well, we can do that if we follow this convention where the field has an underscore s for like a string, or an underscore I for a long. And then we've got this field that says copy field. So it's saying, give me all of the fields above and add it to this full text field. And then I want to make this the default search field. So we want to search on everything. We identify that ID is the unique key, and I'm not too sure what that does. Okay, and if you want this file, I mean, you can take a CSV file that that you have, and you can like map these pretty closely and create your own Solr schema. But if you want this one particularly, it's in the project zip. Okay. And we also have to set up a Solr config. I'm not too sure exactly what this does, except I understand it configures your Solr core, and like it passes some actions onto request handlers. But I know that this file can get very complicated if you look at some of the other out-of-the-box Solr config files that Solr came with. There's a lot of extra stuff like term highlighting and query caching and document caching, and a lot of the magic of Solr can happen in this file, but I kept it very bare bones because I don't know exactly what I'm doing, just messing around. So, okay, so what do we need to do? We need to make a directory of our config set that we want the conf to go in. So to have a conf, you need these two files. And then we're going to put the schema.xml and SolrConf in there. And then, so I've already done that. So I'll just cd into it just to show you. So yes, we already have prison admission conf, cd conf, and then we've got these two files. So schema.xml. So yeah, so we can see that this is the same file that we just saw in the presentation. So we can also see though that there's already some data here. So we're actually going to delete that because we just want to start from scratch as if you were running this demo without these here. Let's also remove the zoo data because that's not there when you start. Okay, so what we need to do is we need to start the Solr server by running this Java command, and that's in the server directory. Right, start.jar. So let's run that. And Word converts hyphens in a funny way, so you might have to edit those. You'll probably have to edit those. Okay, so we're starting our Solr core up. And after we do this, we should be able to launch the Solr admin console again. It won't have anything in it though. So once we go here. Okay, so yeah, it's available, but there's nothing here. So we need to set up, so we're gonna have to open up another terminal, and we're going to have to register our prison admission configuration set with Zookeeper. So we'll run this command. Oh, not there, because we need to go in the right directory. Is that right? CD server, yeah. And hopefully that didn't lead any errors from hyphens getting converted weirdly. But the way that we'll know is if, okay, yay, okay. So we see in here configs. So we just registered our schema and our Solr config with Zookeeper. So now we see this and we're happy. There's no cores available yet though, we haven't done that yet. So what we need to do is we need to create this collection. The collection name is prison admission. We're going to create it with 2 shards, and we're just going to create it with 1 replica per shard. So let's copy that. I'm thinking that's because of the way that the apostrophe is handled. So this should work once we've edited it. Again, Word should stop converting our stuff. Okay, so now if we refresh this, all right, now we've got a core. And so yeah, if we look at the cloud, it's exactly what we asked for. We asked for 2 shards, 1 replica per shard. And so you can query, so if you actually look at the core admin, you'll see, actually, so you'll see no docs on either, because we actually haven't indexed anything yet. So let's actually do that before. Oh, that's not in my PowerPoint presentation. Hang on one second. Oh, okay, would you look at that? So we'll have to add some data to our or we'll have to take the CSV file and add some data to the index. So we cd up one level, as it says in our PowerPoint. Now, okay, so then we paste this command, which again is, oof. Okay, I think it's fine. I don't think there are any formatting issues. But I do think it is still posting the data. So it'll take a little bit of time because it's got, how many rows does it got? I think it's got like 140,000 or something like that. Okay, so that's good. So now if we look at core admin, cool. So we see in this shard, we see 72,000-ish documents were added to this shard, and about 72,000 documents were added to that shard. And when we query either of them, we're going to get all the documents back. So the total of the two numbers summed together. And so this is great. Now we can search among this space. So we can search missing. Just kidding. Why didn't that work? Oh, that's because we did not set up the Solr config.xml file to be very smart. As you saw before, it was really dumb. So we didn't like set the parsing to be smart. So I think if we search actually for missing in all caps, yeah, so we get data for that. So that's one of the things that Solr is great for. It has a lot of out of the box like ways to parse your data, and I decided for some reason to take out a lot of that cool functionality. But if you use one of the out of the box ones, you can see the difference and you can see what Solr provides in terms of like you know, changing your stuff from uppercase to lowercase and then searching among that space, or you can parse out like the words that you don't care about searching, like a, the, it, that kind of thing. But yeah, so we can also search for certain fields. So we could say, give me all the male inmates, and yes. What else can we do? We can browse the schema, so we can see. So if we go back to the gender example, we can say how many inmates are male, how many inmates are female, and then I guess one's not coded. And we can see that distribution. We can see the distribution of age. Or maybe not. Maybe not easily. Some things are harder to parse out than others. Let's see, we could do admission month, like if one particular month is a time when lots of people get admitted to prison. So we could see less in the winter. I don't know. So what do we want to do next? So yeah, so you can ask questions like how many females were admitted between the ages of 30 and 35. Yeah, you can see the distribution of admitting inmates over months in the year. Okay, so using the Solr admin console is great, but it's even better if we can interact with this programmatically. So let me set that up. Okay, so to use Solr, to interface with Solr using SolrJ, we will need to, using Maven, add SolrJ to our dependencies. So you would need these four dependencies. There's a lot of jars in there, but so yeah, not just 4 jars, but so yeah, so we can see that these have been added. Yes, lots of Lucene in Solr. And so we'll start off with a simple query. So we first start out with the URL string that we want to query from. And so we give it one of the shards and replicas, and we use this URL, pass it to the Solr client, ready the Solr query, say, just like in the Solr admin console, we see the query is, give me everything. And so we're just saying that here too. And then we query using the client, we get the response back. The response has, if we look at the response here, oops. If we look at the response here, we get parameters like numFound and documents. But so in here we say, just give me the results. So don't give me the, or no, maybe we do. No, sorry about that. We do get the whole response. And then we say print it to the console. So this is what happens when you run it. So we'll run it here just to show you that I'm not lying. Okay, so it returns back. It says the number of results that I found is this. If we query in here, we see that the numbers match. And then it returns documents. So each Solr document has an ID, has the full text, last known residence, all these fields that we see in here too. And the results match up. So that's good. So this is good, but it could be better. So Solr document lists is, it's a little ambiguous as to what we're expecting to get in response. What we can do is we can create a Solr bean. So if you want to represent your, hang on. Okay, where was I? So, all right. So, okay. So you can get a Solr document list, or you could map it to Solr beans, which is a better way to model your data, because you're more explicit about what you're expecting. So we create this bean with the fields. Again, they map directly one-to-one with the CSV file. They map one-to-one with Solr. And yeah, we give it a constructor that SolrJ can use. I just wrote this two-string method so that the output would be prettier than what's here. And for each field, when you have a setter, you need to identify that it's a field that Solr should map. So this is the Solr field, and then this is your field. So like here, admission year is a Solr field, and we want to set it to one of our bean fields. So we can use this, hang on, okay. So here there's this class called Better Query. So it's very similar to the query before, except instead of get results, we're going to get beans, and we're going to pass it the class that we expect. And we're going to get a list of beans back. So now if we run this one, so we get the same data back, and as we can see, it's using the bean because it's using our two-string method, which had the nicer formatting. Okay, so that's a little bit better. And so we don't just want to query though, we also want to we want to add documents to the index, and we want to update documents, and we want to be able to delete documents. So there's this final class, index, add, update, delete, and we are creating a new document, and we're also adding a new field because we added that dynamic field before that said if you append it with _s, then it'll be accepted as a string field that we can add to our schema. So the way you can do that is in my Solr beam is you have to add this field that identifies that any of the dynamic ones associated with _s can be mapped to this hash map. Here we're creating a new bean. We're setting the fields that we want. So this person Was admitted in May 2015 from Queens, blah, blah, blah. And we're also adding first name is George and last name is Smith. So these fields did not exist there before. Then we say, Solr, please add this bean, and then commit. And once it does that, we query again for this inmate, and we gave it the ID 222222. And so we query for it, and we get a response back saying it's been added. And then we say, oh, okay, you know what? We actually made a typo. We want George's age to be 43 before we put it as 34. Then we query again, and then we'll see that his age got updated to 43. And then we delete him. We say, oh, you know what? We don't care about George Smith. We don't want to record his information. So when we run this one, so yeah, we see all this happening. So first, we add George Smith, and we get a 0 for response, which just means that like it happened. Then we query for him. We see that he was added. He's 34. We send the update saying actually he's 43. We query for him again. It says he's 43. We delete him. We query for him again, and we get nothing back because we deleted him. So yes, that is the demo that shows you how you can interact with Solr. And you can see how it could be easily applicable in like a web application setting where people are, you know, adding data, updating data, deleting data. So like eHarmony, for example, you could add a profile and then make it searchable. So people want to search for, you know, people in the Boston area, and that would be part of like your profile. One of your profile parameters would be like that, and you could, yeah, again, add, update, delete from the index profiles or something. So yeah, so that concludes my demo for Solr. I hope you enjoyed it and learned a lot from it. This was a great class. So have a good night.